Guys, this is the acid etcher. You can see the chemicals in it are very corrosive. It's got a ferric chloride. It reacts with iron, and that's why it's reacted with the iron in the stainless steel, and it's pulled the iron out. That's why it's gone rusty. Right, what we have in this is we have a hanger, okay, and we use this to hold our work. We put our PCB in here and we put it into the etching tank, the jet etching tank. The motor forces hot ferric chloride onto our piece of work, which runs down. It's warm, so it's more reactive. As it runs down, it keeps on being replaced. It keeps on, it increases, or decreases, sorry, the time it takes to actually etch that product. Okay, so a jet etching tank can etch in about 2 minutes, whereas if you had a bubble etching tank, it would take much more, like 8 minutes to etch it. So it's a really good piece of kit. However, because the chemicals inside are so corrosive, we have a lot of problems with the seals and things with it, and it's a temperamental piece of kit. Right, we've got the hanger. I'm going to turn it over, and I'm going to loosen off the two nuts we have. I'm going to put my, can you see I have produced a PCB with the design really close to the bottom there. I'm not going to put that in the bottom like that, because it's likely the bottom bit won't etch. Opposed to that, I'm going to turn it 90 degrees and I'm going to etch it like this. Now, if we look at the hanger, we have these two bars which go across and they have a little groove in them. We've got to make sure our PCB is sitting in that groove. And once that is done, what we want to do is tighten up, not too hard, tighten up those nuts. This should not move, okay? I just slightly compressed each side as I tightened it, so it really does hold it true in the middle there. All right, once we've done that, we are going to come across and put it into the, I did it yesterday for a group and it took 2 minutes exactly. I'm going to put it on for 1 minute and then show you, and then put it on for another minute today. So it is at temperature, it's 46 degrees. We're going to press U. That's the U button. Now, our motor has started. We've got the ferric chloride being pushed against the reactive surface, the copper of the PCB. Reading our time. All right, I'm going to pause after 30 by pressing the start-stop. I'm going to take this out. When I take this out, it's going to have an awful lot of ferric chloride all over it, agreed. What I do is I put it into the next chamber and I wash it using this button here, all right? So, out it comes. We're not going to put it over onto the sink because that's going to get ferric chloride everywhere. We're going to put it into the next chamber, and then we're going to wash it off. And that's going to get rid of the majority of the ferric chloride. And when I pull it out of here, what I'm hoping is it's turned like a salmon pink. Can you see that? And it's turned that colour because we have removed the plastic and the copper is exposed, which is reacting with the ferric chloride. If you pull it out and it's no different to how you've put it in, that is because there's still a layer of plastic over the top and you haven't washed enough away during your developing process. Does that make sense?
Yeah.
Yeah? Good one. Right, so we're now going to, look, some of it is washed away. No, it's not. Put it back in and we're going to start it up again. And pause there.